In this fifth class of chapter 6 of the course of basic geometry, the following topics are presented: polygon regular Nonagon, polygon regular Undecagon, final consideration on regular polygons, and problems to be solved. In this first slide of this fifth class of chapter 5 of this course of basic geometry is present in figure 6.19 a polygon regular Nonagon, which has 9 sides. This polygon does not have an exact construction method. Approximate method for construction is presented. The construction method presented in figure 6.19 begins with the drawing of a circumscribed circumference with center O and radius R. A horizontal diameter is then drawn which tends toward the outer side of the circumference on the right side. At the intersection of the diameter with the curve of the circumference on the right side, we have a point K. With the center at the point K is drawn a circumference with radius R, equal to the radius of the original circumscribed circumference. In this slide, the construction of the polygon regular Nonagon that has 9 sides is continued to be presented. Figure 6.19 is represented. In the intersection of the circumference with center at the point K with the original circumference are determined the points A and D. Starting at point A and passing through the center of the circumscribed circumference draws the straight line segment NA. Beginning at the point D and passing through the center of the circumscribed circumference is traced the segment of straight line DM. Beginning at the point D and passing through the center of the circumscribed circumference is traced the segment of straight line DM. In this slide, the construction of the polygon regular Nonagon is continued. The figure 6.19 is represented. From the point P, the straight line segment PM is drawn. From point P, the straight line segment PN is plotted. These two segments intersect the circumference circumscribed at points B and C. Points B and C form the side of the polygon regular Nonagon. Using the BC side, the other sides of the Nonagon are constructed. As explained, the construction process is not accurate, it is an approximated process. In order to correctly calculate the dimensions of the various elements of the regular Nonagon polygon, it is necessary to use the concepts of sine and cosine for the central angle divided by 2. These calculations are shown on the right side of figure 6.19. This slide shows the polygon regular Undecagon, which has 11 sides. Also is presented its construction and the characteristics of its elements. Figure 6.20 shows the construction of a Undecagon polygon. Initially, it is drawn the circumscribed circumference of radius R. Passing through the center of the circumference is drawn a vertical diameter. On the side of the diameter starting at the point X is drawn a straight line segment having an acute angle with respect to the straight line segment of the diameter. From point X is marked a number of subsegments equal to the number of sides of the polygon to be built, that is, in the case, 11 sides. In this slide is continued the construction of the polygon regular Undecagon. The figure 6.20 is represented. It is used the subdivision method of a line segment in n subsegments presented in chapter 2, article T. The number n is equal to the number of sides of the polygon. These subsegments are designated by the letter X, A, B, C, D, E, F, G, H, I, J, and K. Centered at the point X and the Y arcs are drawn with radius equals to twice the radius of the circumference. The intersection of these two arcs determine the points V and W. This slide completes the presentation of the construction of the regular polygon Undecagon. Figure 6.20 is represented. Now, segments of straight lines are drawn from points V and W through points A, B, C, D, E, F, J, H, I, J, and K. The intersection of these segments of a straight line with the curve of the circumscribed circumference determines the vertex of the regular polygon. In the case of polygons with an odd number of sides, alternate points of the vertical geometry are used twice. For polygons with an even number of sides, each of the marked points on the vertical geometry is used once. The process used for the construction of Undecagon is called the Rinaldini process. As already explained, the process is the approximate process for the construction of polygons with an number of sides. Thus, the exact calculation of the various entities of the polygon requires the use of the sine and cosine values of the half of the value of the center angle. The exact calculations are shown on the right side of the figure. This slide presents some final considerations on the subject of regular polygons presented in this chapter 6. Based on the triangle of the side of a regular hexagon and in the two rectangular triangles generated by half of the side, and in the radius and the apothem, the theorem of Pythagoras is applied. Then you have that the square of the value of the half of the dimension of the side plus the value of the square of the dimension of the apothem is equal to the square of the value of the radius. From this formula, it is possible to calculate the dimension of the side from the value of the dimension of the apothem and vice versa. The calculation formulas are shown on the right side of figure 6.21. In a regular polygon, inscribed circumference has the dimension of the radius equal to the dimension of the apothem. In this last slide of this chapter 6 are presented three problems to be solved. The statement refers to the three regular polygons, a pentagon, Nonagon, and Undecagon, for which there is no exact geometric construction. The problem asks for a comparison of the value generated for the dimension of the side through the construction used, with the value obtained for the dimension of the side by means of the exact mathematical calculations for each order of the cited polygon.